Welcome to Module 1 of Separation Processes 2. In this module, we will explore three important unit operations in chemical engineering: humidification, drying of solids, and evaporation, with a focus on multiple effect evaporators. These processes are central to industries such as chemical, pharmaceutical, food, and environmental engineering. Section 1: Humidification operations. Humidification is the process of bringing a vapor, usually water vapor, into contact with a gas, usually air, so that the gas becomes more humid. Basic principle: when unsaturated air comes into contact with liquid water, evaporation occurs until equilibrium is reached. The air absorbs water vapor, and its humidity increases. Industrial applications: air conditioning and cooling towers. Drying of solids. Chemical processes such as ammonia absorption and natural gas conditioning. Key variables: temperature, humidity ratio, enthalpy, and saturation conditions. In design, engineers use humidification curves and psychrometric charts to understand heat and mass transfer between air and water. Section 2: Drying of solids. Drying is the removal of moisture from a solid material by evaporation. It is one of the most common separation processes. Principle: heat is supplied to a wet solid to vaporize liquid, usually water, which is then removed by a carrier gas such as air. Stages of drying. Constant rate period: moisture evaporates from the surface at a nearly constant rate. Falling rate period: as surface water is removed, internal moisture diffusion becomes the limiting step. Types of dryers: tray dryers, rotary dryers, drum dryers. Spray dryers, used in milk powder production. Fluidized bed dryers, common in pharmaceuticals. Industrial applications: food preservation, drying of chemicals, minerals, and pharmaceuticals. Drying efficiency depends on air temperature, humidity, airflow rate, and the properties of the material being dried. Section 3: Evaporation. Evaporation is the process of concentrating a solution by removing solvent, usually water, as vapor. Principle: heat energy is supplied to boil off the solvent while retaining the solute. Applications: concentration of fruit juices. Recovery of salts from brines. Production of sugar syrup. Factors affecting evaporation: heat transfer rate, boiling point elevation, and fouling of heat transfer surfaces. Section 4: Multiple effect evaporators. A single evaporator consumes a large amount of steam, so multiple effect evaporation is used to improve efficiency. Principle: vapor generated in one effect is used as the heating medium for the next effect. Arrangement. Forward feed: the solution flows in the same direction as the vapor. Backward feed: the solution flows opposite to the vapor. Mix feed or parallel feed, used depending on the nature of the solution. Advantages: significant steam economy, reduced energy cost. Limitations: high capital cost, complex operation, and scaling issues. This concludes Module 1. We have covered the fundamental concepts of humidification, drying of solids, evaporation, and multiple effect evaporators. These processes form the backbone of many industrial operations where heat and mass transfer are involved. In Module 2, we will move to crystallization, adsorption, ion exchange, and membrane-based separation processes.